Hello everyone, and welcome to our session on the future of navigation. I'm joined today by a panel of contributors who we've gathered to discuss how will shipping's digital revolution shape the next era of navigation technologies. I'm delighted to be joined by experts from across the maritime industry, each offering a unique perspective on this topic. To my far right, joining me today, I've got Peter Broadhurst from Inmarsat Maritime. On my immediate right, Richard Doherty from CIRM. Moving to my left, Rakesh Pandit from the Maritime Coast Guard Agency. On his left, we've got Tom Meller, our own Head of OEM Tech Support and Digital Standards here at the UKHO. And finally, Captain Sanjay Shrivastava from OCIMF. Gentlemen, thank you so much for joining us today, and it's particularly nice to be able to do this face-to-face for a change. I'd like to open the discussion now with the first question, which is what will passage planning and navigation look like in 2030? Peter, can I ask you to open up the batting on that?
Thank you very much, Red. Yeah, it's great to be here in the real world and not in the virtual world for the last few months that we've been there. I pick up on your point about the digital revolution. I've been in maritime communications for a long time now, and digital has been a key buzzword, but in maritime, it's an evolution. We're moving forward slowly, and that's what generally happens in shipping. From Inmarsat's perspective, connectivity and providing that digital solutions has been around for a very long time. And what's not really happened is an embraced community within the maritime industry to take that digital solutions and improve the safety, the efficiency and the effectiveness of digital to all seafarers, and moving data backwards and forwards from the ship to shoreside decision-making, as well as on-vessel decision-making. So holistically, we can improve the overall efficiency of maritime shipping, as well as improving the safety. And that's really what I think that we need to focus on. How can this industry move forward? Embrace digital disruption, which doesn't mean the end of an industry. It means actually that the players in the industry will be adding different value. That's all it means. We embrace that and we can move forward and we can overall, as I say, improve safety.
Thanks very much, Peter. Can I come to you now, Richard, for your comments?
Certainly, Rhett. I think by 2030, the global implementation of S-100 is likely to be well underway, hopefully. And I think what that means is that numerous different digital data sets and overlays will be available to bridge teams to enhance all stages of the passage planning process. And if we think what that might look like, I think at the back of the bridge, we will have the physical nautical publications currently in use replaced with digital layers. And I think there will be numerous new novel data sets delivered to planning computers for supporting, for example, weather routing and other types of route optimization. I think at the front of the bridge, S-100 will enable the integration of digital data layers in ECDIS beyond those that are currently available on ENCs, such as, for example, navigational warnings or under keel clearance overlays, supporting navigators in route planning, but also in route monitoring. Some other S-100 product specifications under development that will positively impact passage planning include S-421, Route Plan Exchange, facilitating the interchange of S-100 route plans between ship-based and shore-based systems, but also IEC 63173, which will specify a standardized service interface for the secure exchange of S-100 datasets, importantly making sure that passage planning takes place in a cyber-secure way. So I would say maybe in summary that S-100 has the potential to improve all aspects of passage planning, and in a way that will, as Peter says, enhance the safety of shipping, but also the efficiency of operations, because providing these data sets and integrating these digital layers across systems at the front and the back of the bridge will provide the users with seamless access to harmonized sets of rich data, and that will, in effect, reduce the administrative burden faced by bridge teams.
Really clear, thanks. I think you've really helped us understand some of the layers and the different audiences that we're all working for. Moving on to our next question, if I may, which is how are international standards evolving to meet the needs of hydrographic, maritime and GIS users? Tom, I'd like to come to you first for your opinions on that.
Thank you, Rhett. As everyone will know, and what we've just been talking about there, passage planning is a complex area. And for the mariner, assimilating all of that safety information together is a time-consuming task. They have to have the correct scale charts on their ECDIS systems for planning the route to identify navigational dangers. They have to get the tide tables and things like that so that they can make sure there's enough underkeel clearance for the vessel. They have to have weather information. They have to have the navigational warnings like Richard was just talking about. And gathering together all of this disparate information takes time, and there is a chance that that information may be lost or they may miss some safety information. Now, we've come a long way in 20 years, and I must say it was S-57's birthday recently, and it's celebrated its 20th anniversary in November. And we've done a significant job in providing an electronic navigational chart which can be used in ECDIS and is used on 40,000 vessels globally daily to transport goods around the world. But that standard is now creaking at the seams. It's showing its age. And as a consequence, the IHO have been working on building a new data standard. And this data standard is called S-100, and Richard's already talked a little bit about that. Now, S-100 is a new data framework, and it's built on ISO standards, the ISO 19100 family of geographic information standards. And it encompasses a lot wider range of data than we ever had before within S-57. And as an example, S-100 now caters for data streaming. And this opens up the opportunity to potentially alter depth information directly from tide gauges as you're entering an exit port. So there's some significant benefits that S-100 will bring. Now, S-100 is the framework for hydrographic offices to build product specifications. And the IHO have been busy creating product specifications, as Richard said, for bathymetry, for tides, for navigational warnings. And all of these data layers will be combined together in the new ECDIS systems to present a harmonised view for the mariner. And the reason that we're doing that is to simplify that job of passage planning, to bring together all those disparate information sources into one location and really give the mariner for the first time that simplified view, that safety view, and improve the situational awareness when they're in monitoring mode as well. So S-100 will bring some significant advantages.
Thanks very much, Tom. And given that you've cross-referred, and Richard, you touched on it in signposting in your previous injection, can I come to you for your thoughts on this?
I think from the perspective of the ECDIS user, a common complaint relates to the variation in design across different models of ECDIS made by different manufacturers. In 2019, the International Maritime Organization, IMO, approved Circular 1609, which is entitled Guidelines on Standardization of User Interface Design for Navigation Equipment, the so-called S-Mode circular. Key parts of that circular will become mandatory to implement on ECDIS, INS and radar from the 1st of January 2024 and from all other navigation displays on the bridge from the 1st of July 2025. And that will go a long way to meeting the needs of the user in terms of improving usability of those systems. Another common complaint from ECDIS users, but also from mariners in general, relates to alarm fatigue caused by the increasing proliferation of alarms. The concept of bridge alert management, or BAM, as it's known, has been around for years. And the IMO originally published the BAM performance standards in 2010. Briefly, the concept of BAM is to enhance the handling and presentation of alerts to assist the bridge team in their decision making. And it curtails redundant or superfluous audible and visual alarm announcements, reducing the cognitive load on the operator by minimizing the amount of information presented that's required to assess the situation. However, only recently has a technical standard been developed that will allow the equipment manufacturers to comply with the IMO's BAM requirements. And so now all of those individual testing standards are being updated to include reference to the IMO, to this technical standard, which effectively means that eventually all new bridge equipment will comply with the IMO's BAM requirements, thereby greatly improving the situation on board when it comes to the proliferation of alarms and the concerns around alarm fatigue.
Thanks, Richard. I'm particularly glad that you touched on some of the tech and equipment aspects of that topic, because it leads us helpfully into our next question, which, if I may, is how do we enable the technological and navigational advances shipping needs to unlock new opportunities and advance efficiencies? And with that in mind, can I ask you, Sanjay, to perhaps provide your mariner's perspective to that question?
I guess principles of navigation do not change. And I'd like to agree with some of my fellow panelists that they need to keep evolving. And if you look at the last 20 years, the way technology has evolved, already there's a lot of adapting that has happened in the seafarer and the mariner community in trying to adapt to ever-changing technology. Now, what we really need to keep our focus on is what is the mariner and the operator interface going to look like? And what are the unintended consequences of evolution of technology? Now, we already know about things Richard just mentioned about alarm fatigue. We're also aware about over-reliance of technology and also dilution of navigational skills and principles amongst the seafarer community. But the most important is we're also aware of technology-induced errors, thereby leading to pretty significant navigational incidents. So we have a lot of challenges that we need to overcome. What we really need to keep in focus is the user interface, the focus on safety of navigation, and how changes and advancements in technology is going to overcome these challenges. Now, even as we speak, there is increasing level of automation on board ships. And sometimes we need to kind of really keep the focus on human-machine interface and try and preempt what could be the unintended consequences. And once we've overcome those challenges, I'm pretty positive that advancements in technology, along with advanced data analytics, will lead to real coexistence of technology along with the mariners and lead to better, safer, and cleaner environment and the oceans.
Thank you, Sanjay. Really interesting. Tom, I'm sure you have a view on data sets in this sphere. Over to you.
I think a really good example of how the technology is changing and what we're providing now for mariners to support vessels coming in and out of port is the bathymetric surface, S-100. Now, S-100 is being created to support larger vessels coming in and out of port where there's a requirement to have much higher resolution data than ever before. And as a consequence, there's less underkeel clearance for those vessels coming in and out of port. So mariners need that enhanced view so that they can improve their safety, make sure they're not getting into dangerous areas. The concept of the bathymetric surface is very simple. It's a grid of points which can be altered by the hydrographic office to either increase the resolution or decrease the resolution. And attached to each of those grid points is a depth. And that depth can either be the calculated depth that was measured by the survey crew, or it can be shoal biased by a hydrographic office to be used for navigation. Now, one of the principal benefits of using an ECDIS system, as everyone will know, is setting the safety contour. But using a traditional ENC, there is a rigid set of contours that the ECDIS system can use. And this means that if you were navigating and you put in an 11-metre safety contour, that value isn't available in the ENC information, so it has to default to the 20-metre contour. But that's not the case if you're using an S-100 bathymetric surface. That surface will be able to clearly delineate for the mariner the safe and dangerous areas. Now, the benefit of that for the user is obviously the increased safety, but there's a benefit also for ports who will be able to, if they collect this high-resolution survey information, bring larger vessels in, and also there's obviously an advantage for commercial shipping as they may be able to load more cargoes onto their vessels. So as you can see, that data set, I think, which will be used in precision navigation, will really start to provide technological advances for the shipping industry.
Thanks, Tom. Really helpful expansion for us. Given Sanjay and Tom's points, Peter, are we going to be able to connect all this up?
Well, Rhett, actually, I would say we are already connected, in all fairness. The issue has been that connectivity has always been seen as a cost centre. And so the actual engagement in communications to increase safety and a return on investment for digitalisation has been a barrier. We see vessels transmitting terabytes of data at the top end, the really engaged shipping companies, and then we see vessels with a few megabytes of data at the low end. And so without this kind of strong infrastructure of the right way forward, and I applaud the initiative that's coming from the S-100 in terms of trying to improve the safety, and if we don't have this holistic kind of bringing it all together across shipping, then we will always have a little bit of a disconnect. And I think that's where we have this kind of issue that we need to get through. This is where we need to, how do we really engage shipping to embrace communications to enable what we first started out by talking, which was the digital revolution. And there's a lot that's going on at this moment in time where digital is the underlying thread. The modernisation of GMDSS, all of the stuff that's happening in FAL and in STCW, it's all got this digital aspect to it, and you need connectivity for that. So I believe we are in a connected maritime community. It's just how do we develop it and grow it forward.
And so turning to our final question, which is, in ever busier oceans, how can we use digital technologies to help all ocean activities to safely coexist? And I'd like to come to you, Rakesh, for your opinion and perhaps an MCA perspective as well.
Yes, definitely. I'll be happy to give not just MCA perspective. I believe it's a wider perspective, even from IMO, I would say. Let me take the example of GMDSS and how GMDSS concept is being enriched, will be enriched, probably already is to quite a degree, by new technologies, new digital technologies, digital data transfers, being much faster, much simpler, much more data, but even cheaper and sustainable. You know, as we all know, Apollo 13 probably had similar power as your smartphone now, but you have similar power or similar technological power or similar computing power, but far less carbon footprint, something like that. GMDSS being one example where it is being reviewed. The whole concept of GMDSS is in a comprehensive review since the last few years at IMO. And a couple of things which stand out from there are VDES and NAVDET. VDES as in VHF Data Exchange System, NAVDET as in fully digitized or fully digital NAVTEX. And it is simply said, and my technological friends will agree here, that VDES is supposedly got to be AIS on steroids, and NAVDET is supposedly going to be NAVTEX on steroids, all with a still smaller carbon footprint. So I think that this way the technological advancement, the fact that technology can put together more power and smaller data sets, and that these data sets being harmonized to start with, I think that is the non-disruptive part of technological advances helping, even though the technology itself is disruptive technology.
Rakesh, thank you so much. Peter, what are your thoughts on this, our safe coexistence here?
Yeah, thank you. And that was some very interesting comments from Rakesh, especially around GMDSS, because my main role is safety, and Inmarsat's been providing satellite GMDSS for 40 years. I think we've missed a little bit of a technology introduction within that, in the review of it, because GMDSS is very reactive. We should be more proactive. With digital solutions, there's no reason why we can't be looking at the depth contours on a vessel, identifying vessels in the wrong position, the voyage planning, when a vessel goes astray, and all those kind of things. There's no reason why we can't be on top of this now. In terms of where we want to go is the question. It's not so much what we can do, because we can do it. As I say, there's lots of application providers out there, entrepreneurs providing these solutions. And we are connecting shoreside infrastructure with ship infrastructure, and removing that fatigue, making decisions for people. That's what we're all trying to do here. I mentioned to Richard alarm fatigue. It's people fatigue, really. We create alarms, but the fatigue is on the person, it's on the navigator, and we're trying to take that away. And I think we can be more proactive with our digital solutions, and that drives safety. And, and as I say, my big thing about safety is 360,000 people a year drown at sea. And there's no need for that. And that's what we're trying to do today, is use digital, part of this digital revolution, to move the industry forward so we don't have the accidents. Because the drownings at sea are reported kind of vaguely, but the accidents on ships, we don't really know. And we're just getting into that with crew welfare. And the things that are coming out, again, through the IMO and other charities that are looking at seafarers and the fatigue they go through and the stress they're under. And digital can play a big part in removing that and making our seas safer, not for just the people that are on it, but also for everybody who's involved in it. And I think that's a challenge to the industry on how we need to move forward.
Sancho, clearly there's plenty of opportunities in this sphere, but not without challenge. What do you think?
No, thank you. It's really encouraging to see that there's conscious efforts being taken towards enhancing, improving safety of navigation, and how technology is going to play an ever-increasing role in making sure that that happens. Now, one of the challenges, as you said, increasing traffic density globally, but also there is changes in weather patterns, and there are human factors related aspects that also need to be kind of considered. But what we really need to probably focus on is the reliability of systems that we are going to introduce, build sufficient redundancy within those systems, and make sure that there is repeatability in terms of user experience. So as an operator or a mariner or seafarer moves from one sphere to another, the repeatability of the experience is not one of the challenges that leads to whether it's improper decision making or a contributory factor to future incidents or accidents. Now, I really think there is a great opportunity here in terms of enhancing the way we integrate information into the user experience, and how do we really enhance the quality of decision making in integrating that information into the human-machine interface. And really, in summary, I can't really overemphasize the need, the urgent need to maintain and constantly keep the focus on operator/seafarer training, in ensuring robust reliability of systems, and an unrelenting focus on the human-machine interface and the underlying systems and conditions that people will go through with the ever-increasing technology.
Thanks very much, Sancho. Well, I'm afraid we're out of time, and so it falls to me to draw this session to a close. I feel as if we've only just scraped the surface of what is an iceberg-sized topic, but I know that the panel will have prompted significant thought, and would certainly hope that that will manifest in ongoing discussion and work beyond this conference. Gentlemen, thank you so much again for sharing your time and expertise with us here today.